Hey friends, this is Vidhan. Welcome you to my channel. Today we have a problem from June 2013, part C from Digital Electronics. It looks to be a very lengthy and very big problem, but actually the problem is not big. What you have to do is you have to do a lot of reading to understand this problem, and that's why I will read out the problem for you. It says that four digital outputs VPTH monitor the speed V, tire pressure P, temperature T, and the relative humidity H of a car. These outputs switch from 0 to 1 when the values of the parameters exceed 85 km per hour, 2 bar, 40 degrees Celsius, and 50% respectively. A logic circuit that is used to switch on a lamp at the output E is shown below. Then this is the logic circuit that has been given. Then it says which of the following conditions will switch the lamp on. That means if we put the conditions, then which condition A, B, or C, or D will make this lamp on. That means under what condition or under which condition in the options our final output will be high signal, our final output will be 1, and that means the light will be on. This is what we have to find. Now to properly understand this problem, there has to be a little explanation. It is required. So let us see. It says four digital outputs VPTH. That means VPTH are four outputs from some other circuits. Let us say sensors. There are four sensors in this car. It is a velocity sensor that will produce the velocity whether it is 0 or 1. The pressure sensor, the temperature sensor, and the humidity sensor. Then the question says that velocity sensor, if it senses the velocity of the car is more than 85 km per hour, then it will produce a high signal. That means it will give signal 1, and this 1 will go through the inverter. But if this sensor senses that the velocity is less than 85 km per hour, then it will produce a low signal. That means 0. The value of V will be 0, and that 0 will go through this. This is how we have to think. Now suppose here is a pressure sensor, and if the pressure sensor senses the pressure to be greater than 2 bar, then it will produce a high signal. That means the value of P will be 1, and this 1 will go through this whole circuit. But if it senses the pressure less than 2 bar, then it will produce a signal low signal. That means 0. The value of P will be 0, and that 0 will go through this inverter, and we'll see what happens ahead. Similarly, this temperature sensor, if senses greater than 40 degrees Celsius, then the value is 1. If it is less than 40 degrees Celsius, the value is 0. Similarly, for humidity, if it is greater than 50%, it is 1 high signal, high voltage, and if it is less than 50%, then it is low voltage or low signal, that means 0. So this is how we have to think. Well, finally, how to use or how to do the problem. Very simple, that first of all we will write down a Boolean expression for this digital circuit or the logic circuit. We already know that for a digital circuit we can write the output as a Boolean expression, and that is what we will do. We will write down the Boolean expression for this digital circuit, and we will see we will check for each of the options. We will use first option or the first conditions, set of conditions, and for the first condition we will see that finally do we get the answer or the output to be 1. If we finally get output is high, that means 1, that means the light is on, and our condition is satisfied. That condition will be the right answer. But if for some condition we find that final output is 0, that means light will be off, that means that option is not the right answer. So this is how we have to deal it. For that, first of all, let us write down the Boolean expression for this given circuit. Now the Boolean expression is, here we see that V inverter, P inverter, they are going to NOR gate. That means V inverter and P inverter V goes through this, becomes V inverter, P goes through this, becomes P inverter, and they go to NOR gate, that means operation OR and NOT, that means within them OR and NOT. Then okay, then after we have it goes to and OR operator, that means this part finally goes to a gate with to the OR operator with this signal. Now this signal is, let us write down, T bar, H bar, and this goes to NOR gate, that means T bar or H bar and NOT, and this result separately goes to OR gate, that means this result and this result separately goes to OR gate, and this is it, we have already written. Okay, and this is E. There is no doubt. Okay, so we have understood it. So we have the Boolean expression, but it could be simplified a little. We will use the De Morgan's law. So we will have V bar. Let us suppose V bar is A and P bar is B. Then we know De Morgan's law. De Morgan's law that if A dot B bar is there, then it could be written as A bar plus B bar, and if A plus B bar is there, it could be written as A bar dot B bar. Now see, from this one, if A plus B bar is there, it is equal to A bar dot B bar. Now here B bar is A and P bar is B, you suppose, then it's like A plus B bar, because there is a bar, because it is A plus B and there is a bar, so it should be A bar, that means V bar is A and there will be a bar, dot B bar, B is P bar and there should be a bar, so there should be a bar. And similarly on this, if we use, we will have T double bar dot H double bar. And from double negation law we know that from double negation law, if A double bar is there, it means it is A, that means V double bar is V dot P double bar is P, plus this is T double bar is T and this is H double bar is H. So this is the more simplified Boolean expression we have. Now we will use the first condition. The first condition says that V is less than 85 kilometer per hour, that means V is 0. So for the first condition, V is 0, because less than, sensor senses that it is less than 85, then it produces a 0 signal, I had told you. Then P is less than 2, that means P is also 0 signal. Then it says T is less than greater than 40 degrees Celsius, that means T is 1, high signal, and H is greater than 50 degree, that means H is high signal. Now we will put all these things in that means E equal to V dot P, and that is 0.0 plus T dot H 1.1, and this is 0 plus 1 and 0 plus 1 is 1. This is not algebraic summation 0 plus 1 1, this is actually by Boolean algebra. We know 0 or operation and 1 is always 1. That means under these conditions, under the first option, under this condition, the light is on. The final output signal or from the Boolean expression we have, the final expression is 1. If E is 1, the light will be on, that means it is the right answer. Okay, let us check the second option. It should be 0, because any one option could be correct. The second option says V is less than 85, P is less than 2, that means again V is 0 and P is 0, and it says T is greater than 40 and H is less than 50. Okay, T is greater than 50 and H is, I'm sorry, T is greater than 40 and H is less than 50. So T is greater than 40 means T is 1, but H is less than 50, that means H is 0, I'm sorry. Now using this set of condition, if we write down E again, then V dot P, that means 0 dot 0, 0 dot 0 plus 1 dot 0, we have 0 plus 1 dot 0. By Boolean algebra we know 0, 0 plus 0, 0. So E is 0, that means the light is off. If E is 0, that means the light is off. Now for our checking, let us check, because we are not satisfied. The first option we have got as 1. If any other option comes to be 1, then it would be a confusion. So let us check a little. The third option, V is greater than 85, that means V is 1. P is less than 2, that means P is 0. V is 1, P is 0, and T is greater than 40, that means T is 1, and H is less than 50, that means T is 0. T is greater than 50, that means T is 1, and H is less than 50, that means H is 0. Now under this condition, if we find E, then 1 dot 0 plus 1 dot 0, we again have, this is 0 by Boolean algebra or operation, this is 0. Now 0 or 0 is 0. It seems similarly, if you do for the last option, if you try this, you will find the last option also gives you 0. That means first is the right answer, and under this condition only, if we go through the circuit, then we will find high signal, that means 1, and that will light up the lamp. So the answer is 1. Thank you.